Welcome to CSC 201, Solutions to Practice Exam 1, covering chapters 1 through 4. First problem, we're going to let A be the set 3, 4, 5, and B the set of all x's in the integers such that x is sandwiched between 6 and 10, not including 6 and 10. Okay, so we're supposed to write A using set builder notation. So A is written in what's called set roster notation, where you just list everything. Set B is listed in set builder notation. So I want to switch them, right? Write A in set builder and write B in set roster. Okay, so set A, we could say that is the set of all x's in Z, so the set of all integers, such that 3 is less than or equal to x is less than or equal to 5. So that's one way, right? Or we could say the set of all x's in Z such that 2 is strictly less than x is strictly less than 6. Right, so the difference being here I've put or equal to, so 3 and 5 are both part of this set, meaning integers between 3 and 5, including 3 and including 5, so 3, 4, 5. And then here I've written it, all the integers between 2 and 6, but not including 2 and not including 6, so 3, 4, and 5. All right, write set B using set roster notation. So this is all the integers, the set of all x's in Z, so integers, such that we're sandwiched between 6 and 10, not including the 6 and not including the 10 because it doesn't have or equal signs on there. So we are talking about 7, 8, and 9. So we would say B equals 7, 8, and 9 if we write it in roster notation. A cross B means we create all the possible ordered pairs, all the possible ordered pairs between A and B. So from 3, 4, 5 to 7, 8, 9. So you have to pair every term of A with every element of A with every element of B. So we could have 3, 7, 3, 8, or 3, 9. Those are all the ways you can pair 3 with an element from B. And then we move to 4 and we say, well, 4, 7, 4, 8, and 4, 9. That's all the ways you can pair 4 with an element from B. And then 5. So we could have 5, 7, 5, 8, and 5, 9. So that is all the ways that you can pair an element from A with an element from B. So that's A cross B. Is 6 an element of B? So we go to the roster method for B. Is 6 an element? No, it's not listed. Is 8 contained in B? So this is just incorrect notation. 8 is an element of B, but this says, is 8 a subset of B? So if I wanted this to be true, I could either write, so I would say no because the notation is incorrect here. If you wanted this to be true, you would either say 8 as a set, right, is a subset of B, or you could say 8 is an element of B. Let's define a relation R from A to B as follows. It says that for all x, y in A cross B, so we're looking at all of the points in A cross B up here, x comma y is an element of R, means that x plus y equals 12. Okay. So is 3 related to 8? They're saying, does 3 plus 8 equal 12? No. We want to write R as a set of ordered pairs. So I want to choose all the elements in A cross B where x plus y equals 12. And that's going to be my set R. So let's see. That one, 3 plus 9 is 12. 4 plus 8 is 12, and 5 plus 7 is 12. So R is the set of ordered pairs 3, 9, 4, 8, and 5, 7. It's a subset of A cross B that satisfies a particular condition. In this case, x plus y equals 12. All right, we're going to draw an arrow diagram that represents R. So remember, the domain of R was A, 3, 4, 5. So I've got 3, 4, and 5 elements of A. And then the codomain is B, which is 7, 8, 9. And then we draw arrows that connect them for the relation R. So 3 gets an arrow drawn to 9, and 4 to 8, and 5 to 7. So 3, 9, 4, 8, and 5, 7. Now, does R represent a function? So there were two conditions. Remember, every element of the domain has to be paired with something. So that is true. 3, 4, and 5 all get paired with something in the codomain. And it has to be that each element from the domain gets paired with one and only one element from the codomain. So 3 gets paired with 9, one element. If 3 also got paired with 7, we would not have a function. Okay, so 3 goes to 9 and only 9, so that's okay. If 3 got paired with anything else in addition to 9, it would not be a function. So 4 gets paired only with 8, and 5 gets paired only with 7, nothing else. So we have satisfied the definition of a function. One place where people often get confused is if two elements of the domain go to the same element of the codomain. So for example, let's say 5 didn't go to 7, but 5 were paired with 9. Okay. So in this case, 5 is only paired with a single element of the codomain. So 5 goes to 9 and only 9. We're still okay. It's still a function, even though two elements of the domain go to the same place. That is allowed, okay? But it would not be allowed if 5 went to 9 and 5 went to 7, right? So if I draw this in, now it's not a function. But when I draw it the way I'm supposed to, so that 5 goes to 7 only, it's a function. Yes, because every element of the domain is paired with something, an element from the codomain. So that's the first. And each element of the domain is paired with one and only one element of the codomain.